Here we are in section 2.3, exercises part A, numbers 9 through 13. Number 9, using the formula for a cone, and notice we'll have three of them here, the formula for lateral surface area, the formula for surface area, and the formula for volume. And a calculator, fill out the following table. So let's do that. First of all, we need to know the formulas. For lateral surface area, it's going to be pi r L. Pi times the radius times the slant height. For the surface area, it's going to be pi r squared, that's the area of the circle on the bottom, plus pi r L. And for the volume, that is going to be 1/3 pi r squared h. So we have the three formulas here. Let's put this in and pull them out in the calculator. So for this one, we are going to have pi times the radius is 3 times the slant height, which is 5. So that will be 15 pi. Let's punch that into the calculator. 15 times pi equals 47.12. 47.12. The surface area is going to be pi r squared, so we get pi times radius 3 squared plus pi rl. We already have that one, that 47.12. So we can take that 47.12 and add it to, so hit plus 9 times pi equals, and we get 75.4 is what it looks like. 75.4. Let's clear off a little space. Rewrite that as plus 47.12 equals 75.4. Good. And the volume is going to be 1/3 pi r squared, and then h is 4. And this equals, punch that in our calculator, punch that in the calculator, 1 divided by 3 times pi times 3 squared times 4 equals 37.7. Okay, let's double check those answers in the back. And yes, 47.12, 75.4, 37.7. Good. Now the next one. Radius is 5, height is 12, slant height is 13. The formula for LSA is pi times radius times the slant height. So we will do pi times this radius is 5 times the slant height, which is 13. What will that equal? Let's punch it in our calculator. Pi times 5 times 13 equals 204.2. Okay, the next one, surface area, is pi times radius squared, so that's 5 squared, plus that pi rl, which is the 204.2, and we could do that as pi times 5 times 13 if we wanted to as well. Good. So let's use our calculator. We already have the pi times 5 times 13, so we're going to add pi times 5 squared equals 282.74. 282.74. And the volume is going to be 1/3 times pi times 5 squared times the h, which is 12. The height is 12. So let's pull that out. We get 1/3 1 divided by 3 times pi times 5 squared times 12, and punch that in the calculator all together, and we get 314.16. 314.16. Let's double check our answers. We have 204.2, 282.74, and 314.16. Correct. Excellent. Let's do the next one now. We have a radius of 15, a height of 8 and a slant height of 17. So for LSA, it's going to be pi times the radius, which is 15, times the L, which is 17. So pi times 15 times 17. Certainly don't know that one in my head. Pi times 15 times 17. And that equals 801.1. Good. This one is going to be pi r squared, so 15 squared, plus that pi rl, which we already have is 801.1. And let's see what that comes out to be on the calculator. We have the 801.1, that was the pi times r times l, plus 15 squared times pi. That equals 1507.96. 1507.96. Okay, and the last one. Volume is 1/3 times pi r squared, so 15 squared, times 8. Good. 1/3 pi 15 squared times 8. Let's punch that in and see what comes up. 1/3 times pi times 15 squared times 8 equals 1884.96. 1884.96. Let's double check our answer there. 801.1, 1507.96, and 1884.96. Good. Now the next one. Ooh, the radius is 24. That's a big radius. Height is 7 and the slant height is 25. So in the lateral surface area, we're going to do pi times the radius, which is 24, times the slant height, which is 25. Okay, so calculator. Pi times 24 times 25 equals, that's 1884.96. Okay, on the surface area, it's going to be pi times r squared, so 24 squared, that's pretty big, plus the pi times 24 times 25, which is already right there, 1884.96. Okay, let's do that. We have that plus 24 squared times pi equals 3694.5. 3694.51. Good. And make that decimal a little bigger. All right, and the last one, volume, is going to be 1/3 pi r squared, so that's 24 squared, times the height, which is a 7, equals, let's punch that in, we have 1 divided by 3 times pi times 24 squared times 7 equals 4222.3. 4222.3. Okay, let's look and see what we get. Checking our answer. 1884.96, 3694.51, and 4222.3. Excellent. Here we go. And the last one of this set, we have LSA is pi times radius times slant height, so that's going to be pi times 6 times 10. So punch that in our calculator. Pi times 6 times 10, and that equals 188.49, so 0.5. Surface area, pi r squared, so we've got pi times the radius, which is 6 squared, plus pi times radius times L, pi times 6 times 10, which we have as 188.5. So this is going to equal, let's get our calculator out, we have the 188.5 right here, plus 6 squared times pi, and remember that because we've done this multiplication, this calculator remembers the order of operation and puts it in its right place. So this equals 301.6. Okay, and the volume is going to be 1/3 pi times r squared, so 6 squared, times the height, which is 8. All right, so let's punch those in the calculator. 1/3 times pi times 6 squared times 8 equals 301.59. 301.59. Okay, let's check our answer and see how close we are on these. We have 188.5, 301.59. We put 0.6, that's all right. 301.59. Good. Number 10. If the unit for radius, height, and slant height in number 9, so right here, if they were inches, inches, and inches, what are the units for lateral surface area? Well, first of all, lateral surface area is an area. So it will be this unit squared, inches squared. And we can see that because we have 3 inches times 5 inches gives us inches times inches, which is inches squared, or square inches. Surface area gives you a hint right there. Will also be in inches squared. So this would be inches squared, and this would be inches squared. Highlight those. And then on the last one, volume, however, this is different. Remember, this is a 3-dimensional object, so it'll be whatever unit you're starting with, this time to the 3rd power. Or over here, we would write inches cubed if we were to write the answer with its correct units. Good. Number 11. If the units for radius, height, and slant height in number 9 is centimeter, so if this were centimeter here and centimeter here and centimeter here, then surface area, again an area, will be to the 2nd power. And you can see that because we did centimeters times centimeters to get centimeters squared. Here we have surface area, and again area will be to the 2nd power. And again we had centimeters squared in lateral surface area plus pi, and here's 24 centimeters squared. And then the volume. Volume will be a 3rd-dimensional, or centimeters cubed. And you can tell this because we have a pi r squared, so we're squaring the centimeters and then timesing it by the height, which is also centimeters. So we have centimeters times centimeters times centimeters. Okay, number 12. Using the formula for a cone, one formula at a time, and a spreadsheet, fill out the table in number 9 using the formula abilities of a spreadsheet. So let's open up that Excel document we've been using previously. Put in here the radius, the height, the slant height. We're going to find the LSA, the SA, and the volume of this cone. Good. Let's punch in what the radii are. 3, 5, 15, 24, 6. Move that up a little bit so we can see it a little bit closer. The height were 4, 12, 8, 7, 8. And the slant height, they were 5, 13, 17, 25, and 10. So the LSA, its formula was pi RL. So we're going to equal pi, parentheses, to get it to work pi, times radius. We could put 3 in there, but if we click on this cell, then it will be a variable that we can copy and paste, and that'll be good, times the L. So times the slant height. Good. Enter that one. That's the lateral surface area. And we can copy and paste that, or drag this green handle at the bottom corner of that cell down, and it will copy and paste it. And there we have our 47, 204, 801, 1884, and 188.5. There we go. Good, did it right. Now the surface area equals the pi RL, which we have here. Now we could retype that in, or we can use this cell since it's already figured out, plus the pi times r to the second power. So that's going to call up the lateral surface area that we had before. That's the surface area on the side, pi RL, plus the pi r squared. And we get 75.4. And let's just double check that that's filling it out right. Yep, there's 75.4 in that surface area column. Good. And we can drag this one down. And let's make sure that it gets all of those correct. And yes, you can check that with the answer. Now for the volume, this is equal to 1 divided by 3 times, so that's a 1/3 times pi with the parentheses to make sure it pulls the pi number out, times the radius to the second power times the height, which we haven't used yet, the height, and enter. And so using those variables will allow it so when I copy and paste this or grab on that little green box in the corner and drag, it will then give us the right answers there. We can make this look like the cells in the problem by putting some borders in there, and that's great. Number 13 says open your budget and expense spreadsheet. You created this earlier and actually submitted it to your instructor that you had some budgets that you were creating for a month and keeping track of your expenses. First, make sure that all the budgets and expenses are updated. So did plans to spend money change? Did you have to allot money, borrow money for something? Expenses, did you spend more than you anticipated? Update the last few weeks and make sure that all of your expenses are in there. This has express instructions to use the sum formula. So I'll use it on the Excel spreadsheet that we just had, but you should have expenses in here. I'll show you how to use the sum formula. When you're coming up here, and let's say we wanted to add all of these things up, or add all of these things up, we hit equals and then SUM, and it just sums anything we put in here. And we can just click and drag or type in the range of cells we want it to add up. So for your budget and expenses document, you can add up all of your expenses for the month with a formula like that. Let's do it one more time so you can see it. If we were to add up all these surface areas, we would click on this cell down here, hit equals sum of, and then highlight a range or type it in this format and hit enter, and it added up all of those surface areas. So that should give you an idea of how you're doing it. In your own budget and expenses spreadsheet, you are to do that in there and create cells that are the totals, and you need to use a sum formula. The instructors will be looking for that, and then you'll submit this in your portfolio assignment later on this week. Good.